This is the final video for P2 AQA Physics, just talking about the life cycle of stars and nuclear fusion. So nuclear fusion is all about the joining of two atomic nuclei to form one larger one. So you're adding together smaller nuclei to make a larger nuclei, and you're adding two smaller ones to make a larger one. That's the idea, and it releases energy. The point of this process, just like fission, is to release energy, but instead of splitting an atom, you're joining atoms together, or the nuclei of atoms together. So fusion is a process by which energy is released in stars. So right now, fusion only really takes place in stars, and that's the process by which they release energy. So we need to understand how stars are actually formed. So stars are formed from dust and gas, otherwise known as a nebula sometimes, okay, and they get pulled together by gravitational attraction. So gravitational attraction is putting everything together. Nuclear fusion is producing energy which is pushing outwards. Smaller masses may also form and be attracted by a larger mass to become planets. Okay, so sometimes around the outside there's smaller masses that are left around, and they can become planets. It's part of the life cycle of a star called the main sequence. And during the main sequence period of the life cycle of a star, the forces are stable. So you have a nuclear fusion, the fusion force, radiation pressure we call it, pushing out. So if this is my star here, and you have gravity pulling in, and the size of those two forces will be the same, and therefore the star won't get any bigger or any smaller. Okay, the star goes through a life cycle. Okay, so it actually doesn't just stay as it is; it changes. Okay, and the life cycle of a star is actually determined by the size of the star. So larger size stars have a different life cycle compared to smaller size stars. The fusion process produces all of the naturally occurring elements in the universe, and they get distributed by when one of these larger stars explodes in a supernova at the end of its life cycle, and that distributes the elements across the universe. Those elements are dust and gas, essentially, that could come together to make another star. The only other thing I want to add to this is nuclear fusion. Well, if it's joining atomic nuclei together, it's trying to push together two positive charges. So to do that, it needs to overcome the force of electrostatic repulsion. So it needs high pressure and high temperatures. So nuclear fusion requires high temperature and high pressures because it needs to overcome the force of electrostatic repulsion. That was a key sentence. If you need to go back and play that back and write it down, I certainly would. So just to just go through the process, okay, everything starts as a protostar, dust and gas, okay, and it becomes a main sequence star. If there's a lot of dust and gas, much more dust and gas than there would have been to make our sun, it goes down this route on the right over here. If it's if it's a similar amount of dust and gas then compared to our sun, it goes down this route on the left. So after a main sequence star, if it's a low mass like our sun, it is going red giant, white dwarf, black dwarf. If it's a high mass, it's going to end up going red giant, red supergiant, sorry, not super red giant. But red supergiant, so not super red giant, but red supergiant, and then supernova. When it goes supernova, it explodes, okay, and gives out all the elements. Okay, so all the elements come flying out of that explosion. Okay, the forces of radiation pressure are much larger than the forces of gravity there. You're either left with a neutron star left behind if it's a slightly lower mass, but if it's a massive mass, then it ends up with a black hole being left behind. During the red giant phase, it's getting bigger, remember, so the radiation pressure forces are bigger. Main sequence, remember, the forces are the same size. Red giant phase, remember, the radiation pressure forces are bigger. During the white dwarf, the gravitational force will be bigger than the radiation pressure because it's getting smaller, and similarly with the black dwarf. The key thing to remember from this process is that when a star goes supernova, that's when it distributes all the elements. So the elements that are here on Earth came from a supernova. The supernova releases more dust and gas, okay, a planetary nebula, a nebula, okay, and that can eventually lead to more stars being formed as well. Okay, it's called a supernova and remnant, the bit left behind after the supernova. That it could essentially be a protostar, which then could lead to a new main sequence star. And that ends this video on P2 Physics Nuclear Fusion.